Okay, so now we are going to move into conic sections. We're going to start out with parabolas. So there is a change to your homework assignment. And in this section, I just need you to stop doing the homework when you get to number 61. So let's talk through what we have here on the board. You're going to see a lot of formula kind of stuff over here. I'll talk my way through that. Either write it down or open up your book when you go to the rest of this video, because I'm going to assume that you have these for when I do my examples. So we'll talk about those here in just a second. Let's first start by talking about what a parabola is. Parabola is all the points that are the same distance from a point called the focus and a line called the directrix. Okay, that distance is going to be called P. Okay, whatever that distance is going to be P. So the vertex of the parabola is this point at the very bottom. And then we have what's called the axis of symmetry. And the axis of symmetry runs through the focus and the vertex and ends up perpendicular to the directrix. So here's an interesting thing about parabolas and a really pretty slick use of them. Turns out that anything that enters a parabola, if it is parallel to the axis of symmetry, will be reflected to the focus. And you're like, okay, and how is that cool? Well, for all of you at home with satellite dishes, this is how they work. As the signal comes from outer space, is why they have to point them in just the right direction so they go straight towards the satellite. The signal comes in, it bounces off the parabola and goes to the lens, or the receiver, or whatever it is that they have in front of those things. And so the signal from the satellite comes in just right, it ends up focused there, and then you get to watch television through your satellite dish. Or, for those of you who are, say, football fans, if you've ever wondered how you can hear the middle linebacker absolutely destroy the wide receiver when he comes across the middle, you know, the guy comes across the middle, the linebacker lines him up and just crushes him, and man, you hear it so well on your television set, you're like, that hurts. You can hear that in a stadium of 80 or 100,000 people yelling their heads off because of what's called a parabolic microphone. So if you've ever seen a guy on the sidelines and he's got this kind of half dome shaped clear bit of glass or plastic that he's pointing at the field, that is a parabolic microphone. He points it in the direction of what he wants to listen to, and that's the sound that gets transmitted into the microphone. And that's how you can hear that in the middle of a lot of other noise going on. So anyway, parabolas are kind of cool. They work really well. Let's dig into the nuts and bolts and see how we make them work. Okay, so these are for parabolas whose vertex is at HK, and so we have two different kinds. We have a vertical axis of symmetry like I drew here. We can also have them turn sideways, and that would be the horizontal axis. So the standard form for the vertical axis is this: x minus h squared is equal to 4 times p times y minus k, where the vertex is at hk. And please note, this ordered pair are the two numbers that make 0 inside of those parentheses. And just so we have it, if there is no number here, it's a 0. So if this is just x squared without any other number in there, that coordinate is got to be 0, and that would put you back, could put you back at the origin. The focus is the same x coordinate as the vertex, because we're just going to go straight up to get to it. And we're going to take our y value and add p, right? We said that little distance was p. And then the directrix is the line it's horizontal, so it's y equals a number, and that number is k minus p. And it will be that same thing every single time that you have one of these. Now, it's possible that p is a negative value. If that happens, all that it does is it turns your parabola upside down. Okay, so your parabola would open down, the focus would be below the parabola, and the directrix would be up above. If you have a horizontal axis of symmetry, so again, if this thing were turned sideways, the formula is y minus k squared is equal to 4p times x minus h. The vertex is still at hk. The focus and directrix now, so since we're opening sideways, we're going to go p units out to the side to find the focus and directrix. So the focus will be at h plus p, we're adding it to the x coordinate, comma k. And then the directrix is the vertical line, x equals h minus p. So again, either write those down or probably even easier, go find them in your book and pay attention to them when we go into the rest of this, because we're going to do some examples. All right, so here are excuse me, a couple of examples. So I have one here and then I have another one over there. First, let's try and find the focus, vertex, and directrix for this equation. Y is equal to negative 1/10 x squared. Now, there's a problem hiding with this that maybe we don't see right away. If you go back and look at the standard form that I gave you, or that's in your book, you'll notice that in all the cases we had, the square term was by itself. Okay? There was nothing being multiplied by that square term. So I actually here multiplied both sides by negative 10 so that I can have the x squared by itself. Now, once I do that, I can see I have x squared, I have negative 10y, and the vertex has to be at 0, 0 because there isn't anything being added or subtracted to the x and y. So we're right at the origin. So we still need the focus and directrix. Getting those requires us to find that value for p that was in the standard form. So what we know from looking at the formulas for standard form is that this number here, the negative 10, has to be equal to 4 times p. That's just the way the equation in standard form works. So we divide both sides by 4 and we get p is negative 2.5. That tells me this is actually going to be a parabola that is upside down. It's going to be pointing down. So we have the vertex at 0, 0. The focus, remember, is, since we're going down, 0 and then y plus k, or sorry, k plus p. So since p is negative, 0 plus negative 2.5 is negative 2.5. And the directrix then is the line y equals k minus p. So 0 minus negative 2.5 gives me a positive 2.5. So there's our first example. And here's my second one. Find the equation of the parabola with vertex at the origin and focus 0, 6. So the first thing I noticed is that p has to be 6 here. We have our vertex is at the origin. We have the focus up above it at 0, 6. And we know that p is that distance between those 2 points. Well, since it's 0, 0 and 0, 6, that distance is just the 6. So since it opens up, we're looking at this time having the y be the squared term, right? That's the form of the standard form we're going to need. And so we have y squared, and we have 4 times p. 4 times 6 is 24, and there we go. There's the equation for our parabola. So I have one more example to do. It'll be really fun. All right, here's our last example. And you'll notice it took up my entire board, so this is super fun. We want to find the vertex, focus, and directrix for this equation right here. This is my equation, just in case you're having trouble figuring out where it is on this board. There you go, there it is. All right, so this is going to be fun. You'll notice this doesn't look anything like standard form, and that's really fairly problematic. And so what our first goal is going to be is to take it from the way it looks and move it to standard form. So just kind of hang on, run through this video a few times and see, make sure you understand how this works. So I bring all the y's to one side because the y has the squared. And so in standard form, I need y plus or minus something squared all by itself. So I have the y's on one side, and then I subtracted 3x and added 4 to move those to the other side of the equal sign. So now I'm going to work on getting the y's in the form that I need. Okay, and you can see I work all the way down here and we get to y plus 2 squared. Let's look and see how I get there. So the first thing I do is I say, okay, unfortunately, we're going to have to complete the square. That's the only way we're going to get from something that looks like this to something that looks like that. Okay, that's where we're really going to kind of try and go with this. So, to complete the square, you can't have a coefficient on the square term. So I divide both of these by 2 and factor it out. And then I left a blank, and you can see I wrote the blank in here, and I've already filled it in. Because I need to complete the square on the y squared plus 4y. So I brought the 4 off to the side, because remember, to complete the square, we take that middle term and divide it by 2. 4 divided by 2 is squared. We square it, and that gives me 4. And that is this number right here that I added. Now, for those of you who are paying attention, On the other side, I didn't add 4. I added an 8. And you're going, well, why in the world 4, 8? Those aren't the same thing. The key is right here on this 2. We didn't really add 4 to the left. Because of the 2 outside the parentheses, we really added 2 times 4, which is 8. So that's one thing you're going to have to watch out for with these is sometimes you complete the square, you add that number in, but that's not really what you're adding to that side. So that's why I have an 8 over here. So I cleaned it up a little bit. 4 and 8 makes 12, so we have negative 3x plus 12. And I finished completing the square. Okay, so that's what's going to go inside the parentheses here. So we have this, and now we're getting close. But you'll notice now the right-hand side doesn't look the way it's supposed to. It's supposed to end up looking like this, x minus 4. So what I needed to do, I needed to get that x so that it didn't have a coefficient. So I had to factor out the negative 3. Divided both these by negative 3, we get negative 3 times x minus 4. That almost gets us to standard form. At this point, there's only one thing in the way, just that 2. Okay, that's the only thing that we have that's actually in the way now. So I divide both sides by 2, and that gets us to here, y plus 2 squared. And dividing this whole side by 2 is the same as just dividing the negative 3. So here's my standard form. From that, I pulled the vertex out. So I started there. Remember, the vertex is going to be, this is very similar to what we did earlier in the semester with circles. It's going to be what makes 0. So positive 4 makes 0, negative 2 makes 0. There's our vertex. Now I need p, because I can't find the focus in directrix without p. And I know from the formula that this negative 3 halves is equal to 4 times p. When you get p by itself here, I ran out of room, so I didn't write it down. But you divide both sides by 4, that's the same as multiplying by 1/4, and that's how I get the negative 3/8. So convince yourself of that dividing by 4 here and then multiplying by 1/4 there gives you negative 3/8. That's my value for p. So then I take everything we had about standard form and the focus of the directrix, and I say, oh, this one opens up, or I'm sorry, down, right? Because the square is on the y term, so that means it's either an up or down. It's not one of the sideways ones. And because p is negative, this one has to open down. So the focus is just the same x-coordinate, and then the y-coordinate of the vertex plus p, which is negative here, so you get a negative 2 3/8. And then the directrix is just the line y is equal to negative 2 minus negative 3/8, which, if you work it out, ends up being negative 1 5/8. And that could be as a decimal, because that's a perfectly fantastic decimal. And there you go. Good luck.